So now we're going to switch gears. We're going to try and solve exponential equations. Now if we have a to the x equals a to the b, then that means that x is equal to b. That means those two exponents are the same. So using this bit of information, we're going to try and solve using 3 steps. We're going to make the bases the same so that we have a to the x equals a to the b. We're going to cancel the bases so we have x equals b. And then we're going to solve the remaining equation. All right. Now keep in mind, for this section, the bases should be able to be made to be the same. So solving with different bases is going to require logs, which you'll do in the next unit. So for example, we're going to solve for x, and we have 2 to the x plus 1 equals 8. Now this is what the entire thing looks like, but I'll take you through it step by step. The first step is to make the bases the same. The bases are 2 and 8, where 8 can be expressed as 2 cubed. So by expressing 8 as 2 cubed, we have now made both bases the same. So now we can cancel the bases. Now when we cancel the bases, since both of them are 2, we end up with an equation to solve. This equation that I need to solve is x plus 1 equals 3. All I have to do is subtract 1 on both sides, and I end up with x equals 2. Now here's a more detailed example, more involved, something that you might see on a quiz or a test. In this case, I need to know my log rules. I need to know that 1 over 49 can be made to be 7 to the something. Let's take a look. So we're going to match the bases, we're going to cancel the bases, and then we're going to solve the remaining equation. First of all, 49 is 7 squared. Okay? So 1 over 49 is the same thing as saying 1 over 7 squared, which if you remember your negative rule, you can make that 7 to the negative 2. Now we also have to use that distributive property. The fact that we have an exponent to the exponent means we have to multiply. So that negative 2 is multiplied with the 1 and the negative x to give you 7 to the negative 2 plus 2x. Now we can cancel the bases. When we cancel the bases, we end up with 3x plus 1 equals negative 2 plus 2x. If we bring the 2x to the left side, if we subtract 2x on both sides, we get x plus 1 equals negative 2. And then we just need to subtract 1 on both sides, and we get x equals negative 3. All right, let's get to exponential functions. This is our last part. If b is any number such that b is more than 0 and b is not equal to 1, then an exponential function is a function in the form f of x equals ab to the x. Now that first semi-confusing part is just saying that b can't be negative and it can't be 1. That's basically what it's saying. You'll never run into those. So a in this form is going to be the y-intercept, and the b in this form is going to be called the base. And x can be any real number. So that just gives you a hint to know that domain is all real numbers. Now the base has a lot to do with the shape of the exponential function. If that base is between 0 and 1, if it's a fraction or a decimal between 0 and 1, you're going to have a decay, or your graph is going to always be decreasing. It's going to go down. If your b is more than 1, you're going to have a growth. The closer it is to 0, the slower it's going to be, and the more the higher it is, the faster it's going to grow. So now we're graphing exponential functions. We're going to graph 3 to the x, and we're going to take the long approach on this one just so you guys can see how these graphs are formed, and then we're going to do it a much quicker, more of a sketch of the graph after this. So if f of x is equal to 3 to the x, and I try to fill out this table, I'm going to fill it out using x's from -2 to 3. 3 to the power -2 is 1 over 3 squared, which is 1 over 9. So that's where that comes from. 3 to the -1 would be the same thing as 1 over 3. So that's why the 1/3 is there. And remember, anything to the 0 is 1. So with my input being 0, 3 to the 0 is equal to 1. When my x is 1, I would have 3 to the 1, which is just 3. When x is 2, I get 3 squared, which is 9. And when x is 3, I would get 3 to the 3rd power, which is 27. Now we're going to plot these points on a graph. And that's what our exponential function looks like. Now, when I do ask you to graph this, the most important things that you're going to have to know is the y-intercept and whether it's growing or decaying. Now, the thing that's going to be in common with all of these is that you're going to have a horizontal asymptote at y equals 0. So if you look at the domain, we can go all the way left and all the way right. So my domain is all real numbers, or -infinity to infinity. My range is from 0 to infinity. Now I'm not actually going to touch 0, but it's close enough to say approximately 0 to infinity. For this graph, there is no x-intercept. And for my y-intercept, that's where x is 0. It's going to be 1. Now you'll notice that there is no a on this. When I told you guys earlier, f of x equals ab to the x. If there's no a there, then it's just going to be 1. It's like saying 1 times 3 to the x. Asymptotes, I have an asymptote at y equals 0. That's pretty much going to be the same. And is it increasing or decreasing? It's increasing. That b, the base, is more than 1, and so it is increasing. So let's do another example, but we're going to do it using these 3 easy steps. We're going to first get the y-intercept, which is a. We're going to see if the graph is increasing or decreasing. If b is more than 1, it's increasing. If b is less than 1, between 1 and 0, it's decreasing. Then we're going to draw the graph with the horizontal asymptote at y equals 0. So here is our example. In our first example, 3 was our base. In this example, our base is 0.5. So, 1, let's get the y-intercept. The y-intercept shall be 3, because the 3 is the a. 2, we're going to see if the graph is increasing or decreasing. Since b is between 1 and 0, it's decreasing. And 3, we're going to draw the graph with the horizontal asymptote at y equals 0. So let's put this in. Number 1, we said the y-intercept was 3. Boom, we put 3 right there. Just put a dot. For part 2, we know it's decreasing, but we're not going to draw it yet. We're going to put in our horizontal asymptote. That's the line that we're going to follow. So before that y-intercept is going to be up, and after the y-intercept is going to be down, because we're decreasing. We're going downhill. So my graph is going to look like that.